In our previous videos, we learned how to prepare our model for real-time simulation by breaking it into subsystems, adding OPCOM blocks, and maximizing parallel execution. In this video, we will discuss the Simulink simulation parameters that are mandatory for real-time applications and RTLab. The most important parameter is the type of solver. There are two main categories in Simulink: variable step and fixed step solvers. Let's start by looking at a fixed step solver example to understand how they work. Suppose we have a real, continuous signal that we would like to model in Simulink. We add the necessary Simulink blocks to the model, and the solver subsequently converts these blocks into a set of discrete equations. As the name implies, a fixed step solver generates this signal by calculating the equations in increments of the same size. The solver takes the present state of the system, then calculates the state at the next time interval. It repeats this process again and again, moving forward one interval at a time. The size of these intervals, or time steps, is configured by the user. When the interval is too large, as seen in the center and right images, the final waveform is not representative of the original real-life signal. There is a loss in the accuracy during the discretization of the signal. Of course, a simple solution is to choose a smaller time step to generate a more accurate waveform, as shown here. In offline simulations, we can select time intervals as small as we want. However, for real-time applications, the computation must occur within the set time interval. Therefore, with fixed step solvers, there will always be a compromise between how large we can make our model versus how small we can make our time step. To avoid having to decide the size of the time step, we might be tempted to use the variable step solver. In the same example, notice that the variable time step solver automatically adjusts the step size for the frequency of the waveform in order to provide a better resolution. Where there is little variation in the signal, a larger sample time is chosen to be more efficient. However, the problem with variable step solvers is that they are non-deterministic. At each time step, the same equations may be recalculated multiple times with different step sizes before finding the optimal size. This variability in computation time is acceptable for offline simulations, but not for real time. As a result, only fixed step solvers are supported for real-time applications. The solver type can be configured under the model configuration properties in Simulink. For the solver's order, ODE3 is typically used, but others can also be used for real-time applications. We must also disable the block reduction and signal storage reuse options for the Simulink coder, which RTLab uses to convert the graphical model into C code. These settings can be found under the Optimization tab in older versions of MATLAB, or by searching for them in the settings in newer versions of MATLAB. If block reduction and signal storage reuse remain enabled, some RTLab features may not function correctly.